If you invest $5,000 at 3% interest compounded monthly, after 5 years you will have, we'll use this formula for compound interest, and we will plug in the values that I just gave you. So the total amount will be equal to the initial amount, or the principal, times 1 plus the rate, which is 0.03, divided by the number of compound periods per year, which is 12, raised to the power of the number of compound periods per year times the number of years. If you work that out on your calculator, you end up getting $5,808.08. Now suppose I said you're compounding daily. So if you're compounding daily, the total amount would be what you get if you do 5,000 times 1 plus 0.03 divided by 365 raised to the power of 365 times 5. And you end up with a little bit more, not a whole lot more, $5,809.14. Now suppose I say that we're going to compound every second. Now it turns out there are 31,536,000 seconds in a year. Okay, so if you plug that number into the formula, it turns out, and I'm not going to write that all the way out, you will get something slightly more, $5,809.17. Well, it turns out that if you keep decreasing the length of each compound period, you could compound every half second, every tenth of a second, every millisecond. And if you keep going down to each period being very, very close to 0 seconds, you would say interest is compounding continuously. So there is a formula for continuous compound interest. And that formula is actually easier than the previous formula. The total amount will be equal to the initial amount, the principal, times E raised to the power of RT. P, R, and T still mean the same thing they always did. And E is a number. It's approximately 2.7 and 2.7. And you can find it on your calculator. So now if I do the same problem again, saying that I am putting $5,000 into an account that is getting 3% interest, compounding continuously, need another 0 there, compounding continuously for 5 years, I will end up getting, actually looks like the same amount that I got when I was compounding by the second, $5,809.17. Okay, so how about a problem now? Suppose you invest $5,000 at 3%. Compounding continuous, how much after 10 years? Okay, you may want to stop the video and give it a try yourself. See if you get the same thing I do. 5,000 times E raised to the 0.03 times 10. You should be getting $6,749.29. Now suppose I ask you how long before your money doubles. Well, if you're starting out with $5,000, When your money doubles, you will have $10,000. I forgot the E. Okay. How can I solve that equation? Notice the thing I want to solve for is the t. The t is up in the exponent. Well, before I even worry about that, there's something else I can do pretty easily to help isolate the t. What I'm going to do first is divide both sides by 5,000. So I divide both sides by 5,000, and I come up with the equation 2 is equal to e to the 0.03t. There it is, my t is still stuck up in the exponent. How am I going to get it down? Well, I need to somehow get rid of the e. I need to have some kind of function that will undo the e. Well, there is a function that undoes an e. It's called the natural log function. So what I will do to get rid of the e is take the natural log of both sides of the equation. By definition, the natural log function is the undoer of the e function. So that means that we no longer have the t stuck up in the exponent. And finally, I can solve for t by dividing both sides by 0.03. And I end up with t is equal to 23.1 years. So it would take your money 23.1 years to double if you invested it at 3% interest, compounding continuously. Let's try one more problem. So how long will it take a population to double, now let's say to triple, if it is increasing by 11% per year? Okay, I can hear it now. We don't have enough information. What do you mean? Many people were there to begin with? Don't we need to know how many people there were to begin with to answer this problem? And it turns out, nope, you do not need to know how many people there were to begin with. I can make up any old number. I can say, suppose we start out with 100 people in this imaginary village, and the number of people is increasing by 11% per year. Well, if I start with 100, how many will there be once it's tripled? There will be 300. Okay, then what do I do to solve that equation? First thing I do is divide both sides by 100. And voila, I've got the equation 3 is equal to e raised to the 0.11t. No matter what number I had started out with, if I triple it, put it on that side, and then divide, that's the equation I would end up with. So we'll keep going in solving this equation. I'll take the natural log of both sides. The natural log of 3 is equal to the natural log of e to the 0.11t. I end up with the natural log of 3 is equal to 0.11t. Divide both sides by 0.11. T is equal to the natural log of 3 divided by 0.11. And it turns out that the population would triple after, even rounding to 2 decimal places, 10 years. So that's everything you need to know about solving exponential equations in order to do the next problem set, and I think that's problem set 20. Have a great holiday. Bye-bye.